Lesson 1 is exploring the characteristics of exponential functions. So our goal of this lesson is to investigate the characteristics of our graphs of exponential functions. So recall that an exponential function is a function in this form. Y equals a b to the power of x. The key part is that x is in the exponent. That's how we know it's an exponential function. We have to have a not equal to 0, mostly because if I times anything by 0, it makes the whole function go away. In 30-2, we just have b being greater than 0. So our b values are always positive. And of course, we don't want b equal to 1, because 1 to the power of anything is 1, and that's just a boring graph to work with. So all of these functions in the form of y equals b to the power of x have these exact same characteristics. So 4 of them never change. 1 of them does change according to the function. So our number of x-intercepts, no matter what, is always 0. Always 0. This is because our exponential functions never cross the x-axis. So they always run along the x-axis, but they never cross it. So because of this, we never have any x-intercepts. The one thing that does change is our y-intercept. And our y-intercept depends on what this value here is. So if we know what value that is, then we know what value this is. And behavior is just asking, where does our graph start and where does it end? Exponential graphs always start in quadrant 2 and end in quadrant 1. Doesn't matter if we're growing or if we're decaying. So even a decay starts in quadrant 2, ends in quadrant 1. Domain, again, is something that never changes. For an exponential function, it is always x such that x is greater than or equal to the reals. Y, our range, again, never changes. It's y such that y is greater than 0. So the 4 in pink never change. The only one that does change is our y-intercept in yellow there. So there are 2 different shapes of exponential functions, like I was saying. We have an increasing function, which we call exponential growth. So those were our bacterias, our interest rate, appreciation, anything like that. And we have exponential decay. This is radioactive decay, half-lives, anything like that. That's exponential decay. Now, I had a student once that remembered exponential growth. So if you have a car that starts on the left and it drives towards the right, if it has to go uphill, you know it's exponential growth. But if it starts on the left and drives towards the right, you know, and it goes downhill, you know it's exponential decay. So from left to right goes uphill. That is growth. From left to right goes downhill. And that is exponential decay. In this example here, we're going to compare some different graphs. So Stephanie and Carmen wondered how the characteristics of exponential functions differ from the characteristics of polynomial functions. So Stephanie created a table of values and a graph for each of the functions shown below to investigate similarities and differences. So we have 3 types of graphs here. I'm going to zoom out a little bit so we can see it all. So if we have x up in the exponent like this, then we know that this guy is our exponential. This guy is in the form of that y equals mx plus b. There's nothing fancy here. This is our linear. And if our highest exponent is just a squared, so like this guy here, then we know that this guy is a quadratic. So what we need to be able to do is, if I give you a table of values, need to be able to recognize if it's exponential, linear, quadratic, cubic, something like that. So we're going to look at the y values of each of these tables and see how they differ. So let's look at our exponential one first. So we're going to look at our y values, and we're going to see what happens to these y values. So as you can see, I start really small and I get really big in not that amount of time. So in exponential functions, our y values increase rapidly. So if we go from really small to really big really quickly, we know that we have an exponential function. Looking at the graph here, we can see it kind of looks like a backwards L. And again, we can see that rapid increase. I go from nothing, nothing, nothing to whee, rapid increase. So we can again see that rapid increase. And when we look at our linear graph, again, we're going to compare those y values. Well, I go from negative 12, negative 7, negative 2, 3, 8, 13, 18. So again, we are increasing, but this time we're increasing consistently. So each time I'm just adding 5 to each value. So we're increasing consistently. And that's why we end up with the straight line. Okay. And finally, our quadratic one here. So I go 5, 0, negative 3, negative 4. But then it switches, and I go back to negative 3, 0, 5. So in this one, first I decrease, then I increase. And we can see that on our graph. So first I decrease, and then I hit this point down here at the bottom, and then I start increasing. So this is how we get our parabola shape. That U shape. So there we go. We've compared the tables, how we can recognize the 3 different tables, and how we can recognize the 3 different graphs of these 3 functions. Alright, so for the your turn, you're going to do that exact same thing. You're going to look at the y values in each of the tables, kind of tell yourself, how could you recognize this? What tells you it's an exponential table? What tells you it's a linear table? What tells you it's a quadratic table? And what similarities can you use to recognize the graph? So you can pause the video here. You can do that for yourself, and then come back and see how you did. All right. So, okay, let's see how you did. So of course we can see I got an x up here, so this is my exponential. This is that mx plus b shape, so this is my linear. And we got that squared up there in our power, so this is our quadratic. This one is the opposite of the last one. I started really big and then I got really small really fast. So this one decreases rapidly because it's an exponential decay. But our graph, you can see we still have that L shape. Again, if I look here, I'm consistently adding 8 each time. So I am decreasing at a constant rate. That's how I know it's linear, and I have that straight line. And then for our quadratic, well, first I increased, and then I started to decrease. So we had that turning point where I went from one thing to the other. So first I increased to decrease. And again, we can see that in our graph. First we increase, then we decrease. So we still get that parabola shape. This one is, you know, the upside down U or the N shape. So hopefully you got something like that when you were doing it. Okay, so now you're going to take some time and you're going to practice graphing this on your calculator. So now everybody I saw in our class had the new calculator. The steps for this are pretty much the same no matter which calculator you have, just the screens look a little different. So first you're going to make your stat plot make sure it's turned off. So you're going to hit second y equals, enter, scroll over and hit enter. So when you go second y equals, it's going to bring up your stat plot screen. You're going to look at stat plot 1. If it says it's off already, then you're fine. You can just go to the next step. If it's on, this is when you want to go enter, scroll over to where it says off and hit enter again. All right, so then we're going to go back into our y equals and we're going to clear out any function that might have been in there from before. We're also going to reset our window. So we're going to press zoom and then we're going to hit 6 just to reset our window. All right, so now that everything's clear and blank and new, we're going to input the function. So we're going to go back into that y equals, and using your keypad, you're just going to type the equation. So you're just going to hit 2 bracket 4 bracket, then you're going to hit that caret button to get the exponent, and you're going to hit x. And then you're going to graph the function by pressing graph. If you can't see the graph, which in this case we can, then you would go into your window and you would adjust your windows until you can see the graph. All right. So you're going to follow those steps again. You're going to graph this function. You're going to sketch a little bit of it, and then you're going to state your windows. So again, pause the video here, try this on your own and see how you do. All right, so let's see how we do. So if you graphed this, hopefully you got a graph that looks like something passing through 4, and it's an exponential decrease. So it's going to start up high and come down low. Remember, we do not cross the x-axis. Stating your windows is very important for the diploma. They really like you to show all of your steps, especially what you're doing on your calculator. So when you hit the window button on your calculator, it comes up and it says X min, X max, then it says scale, then it says Y min, whoops, Y max, and it has your scale. So because we reset our window, it should say -10, 10, 1, -10, 10, 1. And that's how we're going to write our values in this form here. So you're just going to say -10, 10, 1, -10, 10, 1. All right. And that's it. So now it's just your homework here. So that's the end of lesson 1.